So hopefully our close event works there. Yep. So we push that X. That triggers the event closed, which in response we set to the window to closed status. The loop finishes, reloads, it runs this logical operation again. Is this open? Well, no, it is not. So we now break from the while loop, we come to the return statement, and the application comes to an end. It exits with code 0, which is proof that it does eventually reach this line. So we have game loop. Now, in general, the way I like to handle drawing to a window is through a separate class. So we are going to make a class here, a header, called main state. So what a state is at any point in your application, you're in some type of state. So in a game, right, for instance, you might have a state for the title screen. And then once you push a certain button on the title screen, like play, it'll bring you to the play state, which is the actual game. So basically it's just sort of a way of organizing every different sort of method of drawing into a different class, so that we don't have one massive C++ file here. Now, I have a feeling this isn't going to get too big. This isn't a very complicated application. But, again, future-proofing. It's always a nice thing to do. So this state is going to be very simple. So, hashtag if not defined main state underscore h define main state underscore h. So we're going to create a main state class. That's going to have both public and private data, although for now we're going to leave those empty. And end our definition. And just to make sure it's very clear, this is for main state underscore h. Okay. So what's this class going to do? Why are we making a class here? It's not going to be a very object-oriented class, I'm not going to lie. This is probably not, from a design perspective, the best way to handle game states. But it's what we're going to do. So quite simply, rather than putting all of the code in our main state, we're going to put it in a function in this main state class. But that function is going to actually be an integer, and we're going to call it render. And it's going to have to take our window, because it's going to be drawing to the window, so it needs the window, obviously. So it's going to take, and obviously for it to take a window, we have to actually include SFML. That is not how you spell SFML. Graphics.hpp. So this is actually going to take as a variable. Wow, just completely forgot what parameter was there. SF render window. It's going to have to be passed by reference because we are going to modify the window. And in this case, we'll just call it window again. It will very likely not modify any private data, so we'll make it constant for now. That might have to be changed later. Actually, it will almost certainly have to be changed later. What am I even talking about? Let's not even do that. Okay, so we have this integer render. So here is the way I usually do this. I set up an integer within main called game state, and we will set it to 1 for now. So every state is going to have a sort of ID. So traditionally, you would do your draw code after you handle all your events. So we would have our draw code down here. So this would be where we put all the draw code. But instead, I'm going to put a little state handler down here. So if state is equal to 1, which is going to be the state ID for this. So if state equals 1, then state equals, and we actually have to make this class exist in here somewhere. So we need a, and we have to include that, of course. Let's not get ahead of ourselves here. Main state.h. So we're going to make a main state called main state here. And if state is 1, then state now equals main state dot render. So the idea here, and then we're going to have an else statement. Just break, I guess. We don't really need an else statement, but it do be that way sometimes. So, in fact, actually, if for whatever reason this number were to somehow get out of sync with an actual state's identifier, and we're going to actually just comment what state is which. So this will be state ID 1. But if for whatever reason this number were to get out of whack, the only reason I can think that would happen is if, you know, somehow we're using all our RAM and things are getting screwed up. But if for whatever that were to happen, we will actually just close the window. So I realized that I used state there instead of game state. Maybe that would be a problem. Okay, now this isn't going to work immediately because, strictly speaking, that's not even the thing. This isn't going to work immediately, even if we do apply everything here. Because it's going to take, well, what am I doing? It's just going to take window. Oh, for the love of God. Can I type today? Okay, so we're not going to get any errors here, but if we actually ran this right now, would not work. Primarily because this render function is not defined. But in that render function, we're going to put all of our draw code. So the idea is if we ever added any more states, we'd make a new if statement. And in this state, we would return our new state's ID so that game state becomes whatever this returns, so it becomes that ID, and then next time we run through this loop, it will start using that state's ID. And in that way, we have a game state handler. Very simple, pretty easy to understand, at least I would say so myself. Maybe not the most efficient way of doing it, but that's what we got. I mean, again, this is not really much of a game, so hopefully it shouldn't matter too much. I don't know. I'm not really sure if this is efficient or not. So let me know. Let me know the logistics of, of what we're doing here. But anyway, this is what we got. And this will work once we actually make our main state. That shouldn't be in header files. Let's go ahead and make our main state C++ file. Main state.cpp, add that. This is going to have to include main state.h, except it's not going to be in that because that's not how C++ works. It's going to look a little something like this. Hello? Okay. And now we're actually going to start defining our classes here. So main state render, which is actually an integer, so we should probably make that clear. Render return 2. So let's say, here's what's going to happen. When this function is, well actually no, I should return 1 by default. So the idea is it's going to run through this code. This will now return 1 by default, which means it'll go back through this cycle again. So it'll keep going through here, seeing the game state is 1, going through here, and running all the code in here, which is basically just doing exactly what it would have done normally in this loop. It would have come through here, did all this, did this, ran again, keep doing that same thing. So that's how update works. So every frame, we have to update the window. And once it reaches that code, that's when it does it. I don't know if that's efficient or not, to be honest with you, but it's what we're going with. I'm not sure if that explanation even made any sense. I hope it did. But that's what we're going to do. So this actually has to take a render window, and that render window is passed by reference. So this is where we'll draw all of our things. And I believe we actually have to run window.update. window. Well, first we have to do clear. I haven't used SFML in a while, and I'm probably going to have to take a quick look at the SFML API before we finish this video. But I believe it works like this. We run window.clear to clear the last frame. Then we put all of our draw code in something a little bit like that. And then we run window.display after we've done our draw code, and that updates the window. So basically, after going through this really convoluted game loop, once it gets to here, it'll clear the window, draw whatever should be drawn this frame, display it, run through it again, clear the window, draw it, display it, blah 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 blah. For right now, this actually now should work, and it does. So because we cleared the window, it went to black rather than white, which is what it was at before, because technically white is something that is drawn on the window. So you'll notice that it is now black, because you can't see it because we're not actually drawing anything, or updating it for that matter. Even if we drew something, you wouldn't see it. But every single frame, it is clearing the window, doing exactly nothing because there's no draw code, then updating the window. And it's going through that cycle over and over again. So, to take full advantage of that, we've now got to start drawing stuff. But we will leave that for the next episode. Thank you for tuning in to Programming Saturdays. Hope to see you next time. Peace.